So today we're going to start with Chapter 9, Real Numbers and Right Triangles, and the first lesson that we're going to be learning is squares and square roots. Lesson 9-1, squares and square roots. So you can go ahead and write that down in your, for your title of your notebook, and don't forget to put today's date. So, all right, so you should have that in by now. There we go. It's just a matter of pointing at the right thing. Okay, so finding square roots. So first of all, we start with the square root of 64. When we think about the square root of 64, we have to ask ourselves, what two numbers multiplied together give you 64? And the two numbers that are the same that multiply together give you 64. 8 times 8 equals 64. Now, what if I asked you what was the square, or what numbers multiplied together give you 36? You would say 6 times 6. Or I might ask you what numbers multiplied together give you 144, and you can say 12 times 12. All of those three numbers, 64, 36, and 144, are considered perfect squares. And so that is something that you're going to be learning about today, perfect squares. And sometimes they're going to be perfect, and sometimes they're not. All right, so first of all, if we start with square root of 64, the first thing you need to understand is this is a positive square root of 64. It does not have a negative in front of the radical sign. If it did, it would be considered negative, and you'll see that in the next example. So since 8 squared, which we learned earlier, 8 times 8 equals 64, then the square root of 64 equals 8. So there's your first answer. Okay? And so 64 is considered a perfect square because 8 times 8 equals 64. Two numbers that are the same multiplied together are considered a perfect square. So you look at example B, 1b, and now you see the negative sign in front of square root of 121. So you ask yourself, what two numbers multiplied together give you 121? And this, of course, indicates that it's a negative square root of 121. So the two numbers that multiplied together would be 11. 11 times 11, or 11 squared, meaning the same thing, equals 121. But since there is a negative sign on the outside of the radical sign, it equals negative 11. Here's another example. Now you have a positive and a negative. Well, what do you do with that? Well, we look at the number. It's the square root of 4. So we know that 2 times 2 equals 4. But this really indicates that the number could be positive or it could be negative. Since 2 squared is 4, 2 times 2 is 4. The square root of 4 could be 2, or the negative square root of 4 is negative 2. So two different ways of looking at it. So now it's your turn. Go ahead and see if you can answer those questions. And those will be 3 questions that we'll look at tomorrow in class. So the square root of 25, the negative square root of 144, and the positive negative square root of 16. Go ahead and write those down. Pause if you need to. I'm going to move on. Okay, so now if we had to use a calculator to find the square root of 23, the first thing you'd say, well, I look at 23 and there's no numbers that multiply together give me 23. Well, you can actually find the number to the nearest tenth, and that's actually what they're asking you to do. So what you have to do on your calculator is you hit the second function, the square root button, or the radical sign, type in the number 23 and press enter. And you should get some kind of an answer that looks like that. Now when we look at this answer, we ask ourselves to the nearest tenth, what do we need to do? Well, since this number 9 is 5 or greater, it tells us that that 7 becomes 4.8. So the square root of 23 is approximately 4.8 rounded to the nearest tenth. And you can see on a number line graph that the square root of 23 is just before the number 5, which is 4.8. And if you ask yourself, 5 squared, or 5 times 5, what does that equal? It equals 25. And so, remember the original question was the square root of 23? They're very close to each other, so therefore, that answer is reasonable. And so that's a good way to check to see if your work is correct. Answer 4.8. Here's another example, and now you'll notice that this is a negative square root sign. And so we have to find that to the nearest tenth, and we still do the same thing with the calculator. Okay, we hit the second function key, square root 46, and enter. Some of you might have to hit equal with that. Just try a few different things and try to get that answer, 6.7823, yada, yada, yada. And the question is, we want to round to the nearest tenth. So this 8 here is going to cause that 7 to become an 8. And so our answer is, don't forget, there was a negative sign here, so our answer is negative 6.8. Now, does that make sense? The square root of negative 46, very close to negative 7 down here. And if you think about negative 7 times negative 7 is 49. Remember, this was 46, the square root of 46, so therefore, it seems reasonable that our answer is correct. Okay? And now it's your turn. You can go ahead and write these two questions down. The square root of 71 and the negative square root of 38. You can go ahead and find those answers using your calculator. Alright, now estimating square roots is a little different. What we're going to do is we're going to ask ourselves, what perfect square does the number 22 fall in between? Well, I think about the number 25, 5 times 5, and I think about the number 16, 4 times 4. So I know the square root of 22 falls in between the square root of 16 and the square root of 25. So, the two perfect squares we're looking for. If you ask yourself, what are the perfect squares? Well, 1 is a perfect square. 1 times 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. And the number 22 falls in between 16 and 25. That's what it's closest to. And so those are the two numbers that we're going to use to try and solve what the answer would be for the square root of 22. So, since 22 is between 16 and 25, we know the answer is going to lie somewhere between them. And when we find this, we have 4 is less than the square root of 22, which is also less than the number 5. Now you have to ask yourself, which one is it closer to? Is 22 closer to 25? 22 closer to 25, or is it closer to 16? And obviously, it's closer to 25, right? So the estimate for the square root of 22, the answer would be 5. Okay. Here's another example where it gets a little bit more difficult. First of all, we have a negative in front of the radical sign, but we also have a bigger number, 319. And you have to ask yourselves, what square root, or what perfect square is closest to 319? So, we have to think of numbers, and it might be a good idea, you know, to try a few different numbers and see what you come up with. And they find that 319 falls between 289 and 324. Okay? So, since they're the ones that are closest to 319, they're the ones that we're going to use. Now, the question is, what is the square root of 324? What is the square root of 289? And we're going to find out right now that the square root of 324 is 18, but then don't forget the negative sign. The square root of 289 is 17, don't forget the negative sign. Alright, so obviously 319, the next question you have to ask yourself, is 319 closer to 324, or is it closer to 289? The answer to that obviously is 324. Since it's closer to 324, the square root of this would be negative 18. Therefore, your closest estimate and your answer is negative 18. That would be the best whole number estimate. So again, your answer is there, and you can actually check that by punching it into your calculator and seeing that it's correct as well. So that's the good news. Negative 18. Now it's your turn to go ahead and answer the square root of 54 and the square root of negative 1 and then 152 in the radical sign. So go ahead and find those answers, and you can pause it, find them, and see if you got the right answers. Okay, so now it gets a little bit more work. We have to read this and we have to do a little bit of work here. It says the observation deck at the Seattle Space Needle is 520 feet above the ground on a clear day. About how far could a tourist on the deck see round to the nearest 10? So, some key words here. 520 feet above the ground on a clear day. How far could a tourist on the deck see? Let's have a look and see what we need to use here. There's actually a distance formula here where they actually tell you about altitude and where d is distance in miles. And this is a set formula that's given to you. So you don't have to memorize this. This is a set formula. D equals 1.22 times the square root of a, where a is the altitude, d is the distance. Okay, so we're going to use that formula. Okay, and we're going to substitute numbers into the formula. Well, what numbers do we have in here? We have the number 520 feet. That is the altitude, how high it is off of the ground. So we're going to substitute 520 into, for the letter A. Now I have to find a number that is the square root of 520. How do I do that? I'm probably going to have to make an estimate because I don't believe that 520 is a perfect square. It happens to be when I punch it into my calculator, if you didn't do the estimate but you do it in your calculator, you can also get the answer 22.8. Okay? And so the last step now would be to multiply 122 times 22.80. And it works out to 27.816. So we would go to the nearest tenth, which is what the question asked us originally, and we would get 27.8 miles. So again, a formula that you don't have to memorize, but something that will come in quite handy. Okay? So now it's your turn. A skyscraper stands 378 feet. On a clear day, about how far could an individual standing on the roof of the skyscraper see round to the nearest tenth? I'm going to give you a reminder of the formula that you're going to use. It's distance equals 1.22 times the square root of the altitude. Okay? You're going to have to use that formula to come to the final answer. So that is the end of lesson 9-1, and I hope that you enjoyed this flipped classroom. See you in the morning.